So last class we talked about mutually exclusive. Today we are talking about independent events. So for independent events, the probability of A and B is probability of A times probability of B. So independent means one does not affect the other. For example, rolling a dice 2 times. You can roll a 1 and a 2. You can roll a 1 and a 1. So one outcome does not affect the second outcome. They are completely separate.
It does or it doesn't?
Does not. Thank you. All right. Conditional probability. So this is your given. This is the symbol for it. When you see that line there, this is the probability of B given A. So just know that notation. It's easier than writing the word given. So that's generally what is used. So when two events are dependent, you have that probability, but really the one that you need to know is, you need to know that formula right here. The probability of B given A, and obviously if one's given the other, then they are not independent, okay, is the probability of A and B divided by the probability of A divided by the probability of the one that was given. Okay, so the intersection of the two divided by the one that was given. And then if they're independent, then it would be that, which means what would happen here if they were independent? They would cancel out and you just get probability of B. But I don't want you to try to memorize that. I just want you to recognize that's what this is saying is if they happen to be independent, probability of A's will cancel. Okay? But really what you need to know is that formula. So Carlos plays college soccer. He makes a goal 65% of the time he shoots. Carlos is going to attempt 2 goals in a row in the next game. A is the event Carlos is successful on his first attempt. B is that he is successful on his second attempt. He tends to shoot in streaks, which means that they are not independent. It's saying that if he shoots one, he has a better chance of shooting the second one. So therefore, they are not independent, okay? So the probability he makes the second goal given he makes the first goal is 0.9. So again, these are not independent. That is an important thing that you have to be able to recognize. What is the probability that he makes both goals? So the probability of B given A is the probability of A and B divided by the probability of A. The probability of B given A is what? 0.9. So this was my probability of B given A right there. Okay? Equals, I'm looking for the probability of both goals, so that's X, divided by, what's the probability of A? 0.65. So multiply 0.9 times 0.65 to get your answer, and you get 0.585. So that is your probability of A and B. Is that okay? Okay, what is the probability he makes either the first goal or the second goal? So this is the probability of A or B. We learned this last class. Anyone remember the formula? Probability of A plus probability of B minus probability of A and B. We're given 2 of those in the problem. You just solved for the third. All right. Are A and B independent? So what's the definition we just talked about? If they're independent, the probability of both equals the two probabilities multiplied. So if they are independent, so what we're checking is A and B, does that equal probability of A times probability of B? So just do that math. A and B, again, we solved for, is 0.585 equal to 0.65 times 0.65. And that answer is no. Are A and B mutually exclusive? What does mutually exclusive mean? Means the intersection is 0. So mutually exclusive is probability of A and B equals 0. Is that true? No, we did that in part A. It was not 0. Make sure you know the difference between these two and how to find them. If I ever say, are these events mutually exclusive or are these events independent, and I've given you math to do, if you don't have the math to back up your yes or no, I will not give you credit, okay? You have to have the math to back this up. You can't just guess. Sorry. So Klaus is trying to decide where to go on vacation. His two choices are New Zealand, A, and Alaska is B. He can only afford one vacation. The probability he chooses A is 0.6, and the probability he chooses B is 0.35. What is the probability of A and B? So what does it mean? What is that probability asking? The probability he does what? Goes on both vacations. 0. He can only afford one, so we know that he cannot go on both. Therefore, the probability is 0. So while it's not specifically stated, it is very strongly implied that that answer is 0. So you can solve it without math. Okay? We're about to talk about that. All right. Probability he chooses New Zealand or Alaska, because A and B is 0. When I do my A or B, when I don't need to do the minus probability of A and B because it's 0, it just goes away, okay? So that means I'm just adding 0.6 plus 0.35. So that is 0.95. So what does the last question ask you? If he goes nowhere. So where'd the rest of that probability go? That means the complement of him going to Alaska or New Zealand is he doesn't go either place. He doesn't go anywhere. So that probability is 0.05. So again, sometimes things are stated specifically, sometimes they're stated implicitly, and you have to figure out what they are. And that's a good example. All right. A community swim team has 150 members. 75 of the members are advanced swimmers. 47 are intermediate. The remainder are novice. 40 of the advanced swimmers practice 4 times a week. 30 of the intermediate swimmers practice 4 times a week, and 10 of the novice swimmers practice 4 times a week. So suppose one member is chosen randomly and answer the question. So first of all, we're going to label what everything is. So I'm going to say A is my advanced swimmers. And there are 75 of them. I are my intermediate swimmers. And there are 47 of them. N are my novice swimmers. And we find that number by doing 150 minus 75 minus 47 because it's the remainder. So that's going to be 28. And then F is practice 4 times a week. So I label those so that way when I use my probability notation P, A, B, C, whatever it is, that way now I know what it is that I'm asking, okay? So what is the probability that the member is a novice swimmer? So what is the probability of N? Say that again. 28 over 150, which is 0.187. Again, either leave it as a simplified fraction or as a decimal or as a percentage. I don't care. What is the probability that the member practices 4 times a week? So what is the probability of F?
40 over 1.
So all of them, not just, so we have 40, 30, and 10 that practice 4 times a week. So it's going to be 80 over 150, which is 0.533. What's the probability they are an advanced swimmer and practice? So this is probability of A and F. So what is the one that combines both of them? What's that number? 40. What is the probability the member is an advanced swimmer and an intermediate swimmer? 0. Good. Are being an advanced swimmer and an intermediate swimmer mutually exclusive? Yes, they are. And why or why not is your justification? Yes, because probability of A and I equals 0. If on that one you said yes because you can't have both and therefore that probability is 0, I don't care how you justify. Just make sure that in some way you're indicating that right there, because that's part of the definition of what it means to be mutually exclusive, is that the intersection is 0. Are being a novice swimmer and practicing 4 times a week independent events? How do we find that out? We have to find the probability of N and F and determine, is that equal to the probability of N times the probability of F? Again, you have to have the math to back up this answer, or it is not going to be accepted, even if it's right, even if you say yes or no correctly. So the probability of both is 10 out of 150. Probability of N is 28 out of 150. Probability of F is 80 out of 150. And so my answer is no, because probability of N and F is not equal to probability of N times probability of F. This is why it's important that you know your notations when you're doing these problems, that you understand what all that means. So that way, A, you know what the question's asking, but B, it's easier to just use the notation versus writing out the words in statistics. Felicity attends Modesto Junior College in Modesto, California. The probability that Felicity enrolls in a math class is 0.2, and the probability she enrolls in a speech class is 0.65. The probability that she enrolls in a math class, given that she enrolls in a speech class, is 0.25. So, what is the probability she enrolls in math and speech? So remember, probability of M given S is probability of M and S divided by probability of S. So plug in what you know. Probability of M given S, so the probability she enrolls in math if she enrolls in speech, is 0.25. We don't know M and S. That's what we're trying to find. And the probability of S is 0.65. Thank you. So we get 0.1625. What is the probability Felicity enrolls in math or speech. So how do I find that again? Add them and, one more thing, subtract the intersection. M or S is probability of M plus probability of S minus probability of M and S. Are M and S independent? Well, probability of M and S is 0.1625. Probability of M times the probability of S is 0.2 times 0.65, which equals 0.13. Therefore, no. Are M and S mutually exclusive? What definition is that? No, why not? No, because M and S is not equal to 0. Again, you've got to be able to answer those questions. Those are going to come up a lot. So if you don't know those definitions, you will have a hard time with it. Okay, example 5. Events A, B, and C are equally likely and mutually exclusive. What does that mean? They have the same probability, so they are all what? 1/3. 0.33, okay? And mutually exclusive means intersection is 0. So what's the probability of A? 1/3 or 0.33? What's the probability of A complement? 2/3 or 0.67? What is the probability of A and B? If they are they are 0. Okay. You have a fair, well-shuffled deck of 52 cards. It consists of 4 suits, clubs, diamonds, hearts, and spades, 13 cards. Okay. Suppose you know that the randomly picked cards are the Queen of Spades, the King of Hearts, and Queen of Spades. Can you decide if sampling was with or without replacement? So what does that mean, with or without replacement? That means I draw a card, and then I put it back. I draw a card, and I put it back. That's with replacement. Without would be I draw a card, and I keep it. Okay? So with replacement, how do you know? Okay, that right there told you you had to be replacing it. Otherwise, you couldn't have gotten the same card twice because there's only one of them in there. So with replacement, because Queen of Spades was chosen twice. If you draw 3 cards and I don't tell you I'm replacing them or not, and I tell you my results were Queen of Spades, King of Hearts, and Jack of Spades, can you decide if sampling was with or without replacement? You do not know. There's not enough, so cannot be determined. In other words, without having any math with it, you can only look at a sample, at the results from a sample draw and determine that it was with replacement. You cannot determine if it's without. There's no way. You can only determine if it's with replacement, and that's if you have repeats, and there's a unique one, okay? All right. Studies show that about 1 woman in 7 who live to be 90 will develop breast cancer. Suppose that of those women, a test is negative 2% of the time. Also suppose the general population, the test is negative about 85% of the time. So the first statement is the test is negative given they have breast cancer. That equals 0.02. The other is the test is negative. Probability of N is 0.85. So make sure you understand the difference between those two. So B is that a woman develops breast cancer. N is that the test is negative. So what is the probability that a woman develops breast cancer? So the probability of B is what? 0.143, 1/7, doesn't matter how you put it. What is the probability that the test is negative? Just the probability that the test is negative. 0.85. Given that the woman has breast cancer, what's the probability she tests negative? So the probability of N given B, 0.02. So again, A and B, we're literally just pulling these numbers from the problem. No math involved. Now we have to do the math with it. What is the probability a woman has breast cancer and tests negative? So this is where I haven't given you enough information, so you have to use a formula to solve. If I have a given statement in there, you're probably using it to find the and statement. So the probability of N given B is probability of N and B divided by what? Probability of B. So 0.02 equals X divided by 0.143. So we get 0.0029. Whenever you get really small numbers like this, if it's not too many zeros, go ahead and do zeros and then go like 2 decimal places, or 2 numbers, past the zeros. Sometimes you will get scientific notation. If your calculator gives you scientific notation, you can write that as an answer. Everyone knows how the calculator tells you scientific notation, right? The E. Okay, so just make sure you just write it out. And again, just do 2 numbers just do 2 decimal places and then times 10 to the whatever it's giving you. So sometimes in probability, you're going to get really big and really small, and that's okay.
How do you know that problem's a given?
Because it says, suppose they develop breast cancer, the test is negative. So we're knowing that they have breast cancer, so this is the probability that they test negative given that they have breast cancer. Does that make sense?
Yeah, but what part of C tells you that you're using that and not the 85%?
Because 85% is just the probability that they have a negative test, whether they have breast cancer or not.
Right.
And so I'm looking for both. Okay. All right. What is the probability that a woman has breast cancer or tests negative? So probability of B or N equals probability of B plus probability of N minus probability of both. One thing you have to be pretty careful about when they're talking like medical stuff and statistics, they're really good at misrepresenting and stating things incorrectly for their benefit, like if it's a drug company. But if you go look at the math, you'll see that their statement is not correct because they're telling you one thing and making you believe another. Similar to like this, the B given A versus the probability of, N given B versus the probability of N. Like, you have to understand how much of a difference there is, especially when you're talking medical stuff, because it's very easy to have 2 things swapped, and that can either look really bad or really good. So you have to pay attention. So if you're going into the medical field at all and dealing with this kind of stuff, that's where all this kind of comes into play. All right. Are having breast cancer and testing negative independent events? How do I know?
Probability of B and an equal probability of
Okay, so we are testing that. So is 0.0029 equal to 0.143 times 0.85. You know, you don't really have to do that math to know that the answer is no. Are having breast cancer and testing negative mutually exclusive? No, because why? What doesn't? Which probability is it that we care about for this? A and or B and N. Given that a woman develops breast cancer, what is the probability she tests positive? Okay, so what this is asking, probability of in complement given B. And that is 1 minus the probability of N given B. Right? So 1 minus 0.02. What is the probability a woman develops breast cancer and tests positive? So, probability of B and N complement. Oh, sorry, I wrote that wrong. That's what we're looking for. Probability of N complement given B is the probability of N complement and B divided by probability of B. So we have what we just found, 0.98 equals X over, is it 0.85? No. Oh, wait, time out, sorry. 0.143. Sorry, I had the wrong number in my head, and I couldn't find it. So we get 0.140. All right, what is the probability a woman does not develop breast cancer? So I'm asking for B complement. So 1 minus the probability of B. And then the last one, what is the probability a woman tests positive for breast cancer? So I'm asking for the probability of N complement. So 1 minus the probability of N, which is 0.15. So do you see how I can ask a whole bunch of different questions and how you just have to know how to manipulate the math? Does everyone see that? Okay. Go do example 8 on your own. By the way, for these, first thing it's asking you to do is find A and B, so list what is A and B, then find the probability.
Where do we write that?
Just next to it. Pretend like there's a blank there. I just don't have a blank there. If you need to draw one, just draw a blank. Does that make sense now? Okay. All right, number 9. Flip 2 fair coins. Your sample space, you can get a heads and a heads. You can get a heads and a tail. You can get tails, heads, and tails, tails, right? Yeah? Okay. So remember, heads, tails, heads are different because your coin, so think of it being a penny and a quarter. Okay? So tails on one and heads on the other is not the same as heads on one and tails on the other. They're unique. What is the or let A equal the event of getting at most 1 tail. So what is another way I can say that? At most. Okay, there you go. So no tails or 1 tail. So we've got to know our middle school math terms. At most, at least, you've got to think about it. If you go on autopilot on this, I'm almost going to guarantee some of you are getting it wrong. You've got to stop and think, okay, what does at most means? It means, oh, I can't have more than that number. Okay, so stop and think so that we don't get easy math wrong. B is the event of getting all tails. So what B is going to be the complement of A. So that means the probability of B equals the probability of A complement, correct? Okay. Therefore, the probability of A plus B is going to be, no, not 0. Remember, if this is the same thing as A complement, what is the probability of A and A complement always equal? 1. So what is the probability of A? Say it. Yep, you got it. 0.75. You get heads, 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 tails, or tails, heads. So 3 possible outcomes out of 4. Probability of B is 0.25. While it's not that hard because you only have a sample space of 4, it's, again, easier to find the probability of A by doing 1 minus the probability of B because you only have 1 in probability of B, and that one's easy to count. Let C be the event of getting all heads. So what is the probability of B and C? What's the probability of getting all heads and all tails? 0. So therefore they are, what do we say? Say it louder. Mutually exclusive. In case you haven't noticed, I have talked about mutually exclusive and independent a whole lot, so it's important. Make sure you know it. D is the event of getting more than 1 tail. What does that mean? Getting all tails, 2 tails. So the probability of D is 1/4 or 0.25. The probability of E getting a head on the first toss. So what are my 2 outcomes? Head, head, and head, tail. So 2 out of 4. And, yeah, 50% or 1/2. F is the probability of getting at least 1 tail. So what are my options? Head, tail, tail, head, and tail, tail. So the probability of F is 0.75 or 3/4. Draw 2 cards from a standard 52 card deck with replacement. Find the probability of getting at least 1 black card. So what are my outcomes? I can get a black card on the first draw and a black card on the second draw. I can get a black card on the first draw and a red card on the second draw. Red, red, and red, black. So, getting at least 1 black card, there are 3 of those, so 0.75.
What if we don't know anything?
Example 11, flip 2 fair coins. Find the probability of the events. I want you to do these on your own. You got this. First of all, write out your sample space. Okay, let event A be learning Spanish. Event B is learning German. Probability of A and B is learning both, and then it gives you your probabilities. What is the probability of A complement?
0.6.
What is the probability of B complement? Are events A and B independent? So what are we checking? Probability of A and B equals probability of A times probability of B. So probability of A and B is 0.08. Probability of A is 0.4. B is 0.2. Are those probabilities equal?
Yes.
Yes, they are. Therefore, yes, they're independent. In a bag, there's 6 red marbles and 4 green marbles. Red marbles had numbers 1, 2, 3, 4, 5, 6. Green are 1, 2, 3, 4. Sample space R is a red marble, G is a green marble, O is an odd numbered marble. And that gives you your sample space, R1, R2, R3, R4, blah, blah, blah. What is the probability of G and O? So the probability of getting a green marble with an odd number. 2 out of 10. Not 0.02, sorry, 0.2. There we go. Last one. All right. In a basketball arena, 70% of the fans are rooting for the home team. 25% of the fans are wearing blue. 20% of the fans are wearing blue and are rooting for the away team. Of the fans rooting for the away team, 67% are wearing blue. So A is the event a fan is rooting for the home team, the away team. B is the event the fan is wearing blue. So first of all, are they rooting for the away team and wearing blue? Are those independent, and are they mutually exclusive? So first, find the probability of A. A is that they are rooting for the away team. So we're going to find that is 1 minus 0.7. 1 minus the probability they're rooting for the home team, right? What is the probability that they are wearing blue? 20. So that one told me that in the problem, so 0.25. What is the probability of A complement? 0.7. B complement? 0.75. And probability of A and B, that they are rooting for the away team and that they are wearing blue. 0.2. The last bullet is one of the givens. The probability of this giving this. So 0.2. All right. So to find independent, what do we check? Probability of A times probability of B. Does it equal probability of A and B? So A 0.3 times 0.25, and that gives me 0.075. So are they independent? No. Are they mutually exclusive? No. Which does not equal 0.2. That I should have finished that statement.